Hi there, Chemistry B students. My name is Miss Miller and I teach at Garfield High School. This year I'm teaching Chemistry B, Physics B, and Environmental Science. In this video lecture, I'm going to go through something called dimensional analysis. Now, before we get started, I'm going to talk about what we've been doing in this class and how this fits into the general context. So previously in Chemistry B, we started this unit with this spicy peppers elicitation, where maybe if you were lucky, you got the chance to taste some spicy peppers and make some hypotheses about what makes one pepper more spicy than another. Then we've gone through an introduction to the concept of what a mole is in chemistry. We went through a little bit of an interactive lab simulation where you were looking at what do different quantities of a mole look like for different substances. Later, based on measuring the mass of a known substance, you'll be able to calculate exactly how many moles or molecules are in a given sample or substance. So we're going to go through this process called dimensional analysis to help you with a framework for how you can go through doing these calculations, where we'll be converting typically grams that we've weighed on a scale to moles, ultimately so that we know how many molecules or atoms are in a sample. So the learning goals for this dimensional analysis lecture are that after watching and practicing the problems in the video, you'll be able to convert between units and solve problems using this process of dimensional analysis. I want to make a note here that the examples in this lecture are outside of the context of chemistry so that we can introduce the concept of dimensional analysis. But moving forward, you'll be mostly using calculations that are within the context of chemistry while you're using this method. Okay, so let's start off with what dimensional analysis is. We're going to start by just breaking down this word into kind of its root words. So I see here we have the word dimension, and then we have the word analysis. Now, dimensions, when you think of dimensions, you're usually thinking of a unit associated with some amount of measurement. So when I think of a dimension, I'm often thinking about how many centimeters long something is, or meters or inches. So the dimensional part of this is really having to do with the units. And then analysis is a broad term that really means it's a process of answering questions through reasoning or calculations. So when we're performing dimensional analysis, we're going to be focusing on the units and doing calculations by following units here. So in general, the definition of dimensional analysis is the process of using fraction multiplication to solve problems by canceling units. And it's going to look something like this, but we'll get into the nitty-gritty here in a moment. Now, I also want to point out that sometimes your teacher might refer to this as unit cancellation. It's the same process as dimensional analysis. So why is it so useful? Well, there are so many everyday quantities that are expressed as ratios. Like you might say that Isaiah makes $16.50 per hour. All right, this means that he makes $16.50 per hour. So we can write that as a fraction or consider it a ratio. There are 7 days in 1 week, so we could write that as a fraction, 7 days over 1 week. In the medical field, you often talk about ratios. So a patient needs 20 milliliters of fluid per kilogram of body weight. So we can also write that as a fraction here. So ratios really tell us how two different measurements, units, can be made equivalent to each other. So 1 hour of work is equivalent to $16.50 for Isaiah. 7 days is equivalent to 1 week. Or 20 milliliters of fluid is equivalent to 1 kilogram of body weight. So here's how we can use dimensional analysis. So it's this process of using fraction multiplication to solve problems. So we need a problem to start with. So we're going to ask the question, how much money will Isaiah make after he works for 6.5 hours? First thing we want to identify is what are we looking for? So we have our given information that Isaiah makes $16.50 per hour and that he works for 6.5 hours. So we want to start by actually writing these as equivalencies if there's a ratio there. 1 hour of work's equal to $16.50. Now in the problem, we can see that we're looking for money. So we're looking for something with the final units of dollars. So I'm going to set up a fraction that has $16.50 on top per hour of work. And then I'm going to multiply by another fraction that shows that I have 6.5 hours over 1. And it's over 1 because we don't have a ratio with 6.5 hours. It's just 6.5 hours on its own, and we put it over 1 just so it looks like a fraction. Then we're going to multiply across. Fraction multiplication, you always multiply the numerators together and the denominators, so we multiply across. Here, the beauty of dimensional analysis is that we end up with hours here and hours here. So we have hours in the numerator, hours in the denominator. That means that our hours will cancel out and we'll be left with the remaining unit that we desire, which is dollars. So at this step, all we have to do is multiply the numbers and then get our final answer. Here it is written in its final form. Now here's another example, and I'm going to go through the steps one by one. Here, Audrey's planning to drive to Portland from Seattle, which is 175 miles. Her car's fuel efficiency is 38 miles per gallon. If the current price of gas is $2.85 per gallon, how much money will Audrey have to spend on gas for this trip? So step 1 is to identify the desired units for the final answer and the given information. So the final question here was, how much money will Audrey have to spend on gas for the trip? So we're looking for a final answer in the form of dollars. Other given information we should list as equalities. So we have our desired units, and then the given information in bullet form. We have 175 miles. We know that 38 miles is equivalent to 1 gallon of gas for her car. And we know that $2.85 is equivalent to 1 gallon of gas for the car. Now, the next step is to set up one of these equivalencies as a fractions that has the desired units in our numerator. So our desired units is money. That means that we're going to start with dollars, the equivalency that includes dollars, in our first fraction. So we're going to take this equivalency and write it as a fraction. So we have $2.85 per 1 gallon of gas. So we've done step 2. Next, we're going to go on to step 3. So we want to multiply by a second fraction. So we're going to set up a second fraction such that the units of the denominator of the previous fraction are the same as the units as the numerator of the new fraction. So if I look at the denominator of the previous fraction, it was gallons of gas. I'm going to pull up our bits of information that we are given, so we have them available here. So in the next fraction, what I want another fraction that contains the same units that are in the denominator here. And if I look at what's left to use of the information, I have this equivalency here that contains the units of gallons of gas. So I'm going to set up another fraction that has the gallons of gas in the numerator and the miles in the denominator. So I've used that bit of information. Then we're going to cancel the units that appear in the numerator and the denominator. Just as before, we saw that when we have units in the numerator and in the denominator, they will cancel out. So I can cancel out these units. Then we're going to repeat step 2. So I'm going to look at the units from the last fraction in the denominator as miles. That means my next fraction should have miles in the numerator on top. And sure enough, I have 170 miles here as a bit of information to use. So I'm going to multiply by a fraction that has 175 miles over 1. Here, the units can cancel because I have units in the numerator and units in the denominator. And then we'll move on to the next step. So you'll notice that the only units that are left are the desired units of dollars here. Step 5 is to multiply across, right? So when we multiply fractions, all of the numerators are multiplied together and all of the denominators are multiplied together. So here that is set up. You'll notice that the units are still there, but the only units left are dollars at this point. Then multiplying, I get $498.75 over 38. And then the last step is to divide the numbers here. We have the numerator divided by the denominator to get our final answer of $13.125, which we should round to the nearest hundredths of a cent, and we have our final answer there. All right, here's another one that you can try. So I'm going to let you pause the video here, read through the problem, and here are all the steps to follow for solving this problem using dimensional analysis. So pause the video now and see if you can solve this one on your own. All right, hopefully you've given that a shot, and here I'm going to go through the solution. So step 1 is to identify what we're looking for. We're looking for how much money Isaiah will make in 1 month. Then we want to list all of our given information as equivalencies with units. Next, we start with our first fraction that includes the desired units of dollars on top. So we have $16.50 per hour. The next step is to then multiply by another fraction that will cancel the hours from the denominator of the previous fraction. So I am going to cancel out hours with hours, using the fraction that 7.5 hours is equivalent to 1 shift. Moving forward, we want to cancel the units of shifts. So I'm going to multiply by a fraction that has shifts in the numerator. And I can cancel shifts with shifts. And then I'm on to the next denominator of weeks. So from here, I multiply by 4 weeks over 1 month and can cancel the weeks. And then the last step here, which is sort of a bonus step of multiplying by 1 month so that our final units really are just in units of dollars. Finally, we're going to multiply across, so numerators together, denominators together. What's nice on this one is that all of the denominators are 1. And then when we multiply the numbers together, we get our final answer. So Isaiah's bringing home $2,475 in that month. I want to point out that sometimes instructors will write these dimensional analysis problems this way, where instead of separating out the individual fractions, they draw one long horizontal line and then vertical lines to separate their fractions. This is the exact same mathematical process. It's just that instead of writing the multiplication symbol between fractions, we have these vertical lines. And then from there, you're just multiplying across again and getting the final answer. Okay, I have one more for you before you go. So read through this problem and again, try it on your own, and then I'll finally go through the answer. So pause the video here and give it a shot. Okay, here's our desired units. Here's our bits of information. We're going to set up our fractions so that the units will cancel. And then we will multiply across and do one final division to figure out how many fluids the patient needs. And here it is set up with the alternative kind of notation with the vertical lines. Okay, so in summary, we've learned about dimensional analysis in this video, that it's really a process of using fraction multiplication to solve problems by canceling units. Hopefully you're feeling more confident in your ability to do this now, but there can be more practice from your instructors if you ask them. Here's what that looks like. And then one more thing is that I want to bring up that coming forward, you're going to be using dimensional analysis to solve problems in chemistry. So what that might look like is that in the chemistry lab, you'd weigh out a certain amount of some substance, let's say sulfur, which is this nice yellow powder. And the question is, how many moles of sulfur does your sample contain? I just want to point out that you can do the exact same process here, and it works out just